For example number 2, we're going to let 2, negative 3 be a point on the terminal side of theta, and we want to find all 6 trigonometric values of theta. So the first thing we're going to do is we're going to sketch the ordered pair 2, negative 3. Let's do that over here in red. So 2, negative 3, we're going to go 2 units over on x, 3 units down on y, corresponds to this angle right here. So we know the following. We know that x is equal to 2, and we know that, that y is equal to negative 3. Now remember, in order for us to find all three, in order for us to find the trigonometric values of theta, we need 3 values. We need x, we need y, and we need r. So one of the interesting things is that r, so I want you to understand where the formula for r came from, and then we'll apply it. But r is really the radius of the circle right over here, taken where one of the points on the circle, one of the points of circumference of the circle is the ordered pair 2, negative 3. Now again, we know if we're looking at this circle, we can figure out what this distance is right here by using the Pythagorean theorem. We can figure out r using the Pythagorean theorem. Because we can turn this into a triangle. And so I'm going to make some dashed lines over here to help you represent the triangle. I don't know if you can see this. There's a little right triangle over here. We know that x is 2, so this value over here is 2. We know that y is negative 3, so this value over here is negative 3. And then we can use the Pythagorean theorem to help us find r. Now remember that r squared, remember the Pythagorean theorem tells us hypotenuse squared is side squared plus side squared. So we know that r squared is equal to negative 3 squared plus 2 squared. The formula we see in your textbook says that r is equal to the square root of this, because if we wanted to get rid of the squared, we could take the square root of that. So we end up with r is equal to the square root of negative 3 squared plus 2 squared, and that gives us the square root of 9 plus 4, and that tells us that r is equal to the square root of 13. There's nothing we can do to simplify that. Now we have our 3 values. To figure out the trigonometric functions, we know that x is 2, y is negative 3, and we know that r is equal to the square root of 13. So let's find all of the 6 trigonometric values for theta over here. So the sine of theta. Okay, well, sine is y over r. Y is negative 3. R is the square root of 13. We rationalize that, and we end up with negative 3 square root of 13 over 13. Cosine of theta, cosine is x over r. We know x is 2. We know r is the square root of 13. We rationalize that again, get rid of the radical in the denominator, and we have 2 square root of 13 over 13. Tangent of theta, tangent is y over x, so we have negative 3 over 2. All right, so these are the initial 3 trigonometric functions. For their reciprocal functions, cosecant of theta, remember that cosecant is just the reciprocal of sine, so we can call it negative square root of 13 over 3. For the secant of theta, and remember that secant is the reciprocal of cosine, so we can flip this over here, we get the square root of 13 over 2. And for the cotangent, for the cotangent of theta, we just take the reciprocal of tangent and we get negative 2/3. And here are 6 trigonometric values.